In this video, we're going to take our first steps in writing source code. And the way we're going to approach this is that we're going to write a simplified version of the TicketMachine class. Now, one of the reasons for doing this is that you've already observed how a ticket machine works in practice, and there's source code available. So if you need to refer to it, if you get stuck, then you can go and use that as a source of extra information. But hopefully in the steps that we'll take within the video, it'll give you a chance to learn how to write source code for yourself. Certainly take the first steps towards doing that. Now, we need to begin to introduce some bits of terminology, Java terminology, and these concepts will be quite important from this point onwards. So up to this point, we've been talking about items of data and data values with respect to objects, and Java has a particular word that we use for that, and that's the word field. So those things that can store data inside an object, each one of them is an individual field, and we'll see what that means in practice in source code in a little while. When we create an object, its state is initialized, and that's performed through the execution of something called a constructor. So constructors are the initialization points for an object state. And then when we want to manipulate the data inside an object or find out what data it's storing, then we'll be calling methods. And as mentioned before, methods provide read-write access to an object's state. So objects store data. The data values represent an object state. Each data value has a data type, and we've seen the types string, int, and boolean up to this point. Methods allow us to interact with objects. Methods allow us to read or modify an object state. So we've already explored the behavior of a typical simple ticket machine through the naive ticket machine project. Machines supply tickets of a fixed price. Money is entered into a machine, and the machine keeps track of how much money a customer has entered. And then when the customer's entered enough, the machine will print a ticket for them. Now, for our exploration of how to write source code, I want us to think about really these four fundamental aspects of the way that we learn anything, not just writing programs. If you think back to the early example I used of people learning to surf, you'll appreciate that part of their learning process involved observing. So a teacher showed them the kind of positions to stand on a surfboard. They will have observed that and then sought to imitate the way to stand on a surfboard on their own surfboards. So they observed, they imitated. But then when they came to try it out for real, in the sea and on waves, they most likely fell off, and they most likely fell off many, many times in initial stages. And what I said when talking about that example was, hopefully what they will have done is reflected on what worked and what didn't work, and then made some adjustments the next time they tried to surf. And that via this process of repetition, perhaps even going back and talking to the teacher or re-observing what the teacher had done and then seeking to imitate that more perfectly, they would eventually get the hang of learning to surf. And the same is going to be true of learning to program. I'm going to give you lots of examples of source code for you to observe, and then I want you essentially to imitate what you see. Now, when you imitate what you see, you won't simply be duplicating the code that you see, because it won't necessarily be appropriate exactly in that form for the new situation. So if I'm asking you to write the code for a ticket machine and you simply imitate the code for a triangle, then you'll get a triangle rather than a ticket machine. So your observation and imitation will require some adaptation to understand the overriding principles, but then the ways in which you need to adapt in order to make the imitation work for a new situation. And that might involve reflection. And then you repeat, and eventually you'll get there. It's the nature of learning that a lot of repetitions often required before you finally get there. So the way that observation and imitation is going to work with writing source code is we're going to start looking at the internals of classes that we already understand. In particular, we're going to look at the internals of triangle and the internals of ship, a couple of examples that you will already have seen. We're going to observe the common elements of the source code of those classes, and then we're going to imitate those in creating new classes while adjusting our observations to fit the new context. And by going through that kind of cycle, we'll eventually develop a class that behaves like the ticket machine that we've seen. Now, I can't stress enough that in the early stages of this imitation process, errors will be common, and I hope you won't be discouraged by that, because that's the normal way in which we learn things. Most of the time, as part of our learning process, we're going to be making errors, and it's that process of reflection and repetition that gradually allows us to reduce the number of times we make errors. But we'll always make errors. I've been programming for decades and I still make errors in the way that I program. So it never goes away. The main thing is don't be discouraged if you do find that you're making errors. So let's start thinking about and looking at parts of the source code of some classes that we're already familiar with. So here we've got the outer wrapper of the triangle class and the ship class. And you should be able to see fairly easily that there's very little difference between the outer wrappers of those two classes. One says public class triangle, then on the next line there's an opening curly bracket, a bit of blank space, and then there's a closing curly bracket on the line underneath there. So that's triangle, but for ship we've got public class ship, a new line, an opening curly bracket, bit of space, and a closing curly bracket. The only difference between the outer wrapper of a triangle class and a ship class is whether we use the word triangle or whether we use the word ship. And this is something that you will imitate in absolutely every class you write. If you wanted to write a class called square, then you'd write public class square, you'd have an opening curly bracket, some space, and a closing curly bracket. If you wanted to write a class called circle, you'd write public class circle, you'd have an opening curly bracket and a closing curly bracket. So by memorizing and imitating the form that you see here, you can now write a class of whatever name you wish to. So what we can say is that the outer wrappers of classes have a common or standard form in which we use the word public and class, and then the only variation is the name of the class that we're seeking to create. So you might like to pause and maybe even write down on a piece of paper what the outer wrapper of a ticket machine would look like, because from this observation you should be able to imitate that style and then create your own outer wrapper of a class called ticket machine. So what about that blank space between the opening curly bracket and the closing curly bracket? Well, clearly we need to put something in there. That's where the internal definition of our class is going to go. That's where things like the data definitions and the initialization for objects and the methods that provide us access to the data are going to go. So we can extend this idea of a general outer wrapper to say inside that outer wrapper, so between the opening curly bracket and the closing curly bracket, we will typically find three distinct things. And in Java, these things are what are called members. And those members have names, or more distinctive ways of describing them. We have members called fields, which in other words are the data items that objects of this class will have. Another member is a constructor, or you might like to think of a constructor as being an initializer. It's the place where each object that's created from this class gets its initial state, its initial setup. So for instance, for something like a triangle, it'll be whereabouts the triangle will be, how big it will be, what color it will be. Those are all initialized inside a constructor. And then the rest of the class, which is typically the bulk of the rest of the class, most of your code that you write in a class will be for this type of member, which is where we write the methods or behaviors. We sometimes describe methods as being behaviors. And so far we've characterized methods as being the parts of the code that provide us with access to the data, in other words, the values stored in the fields, and we can either read or write that data that's inside an object. So that's the general style of a class. Let's look at how that maps to a particular class. Let's look at how that maps to the internals of a triangle class. We've got the outer wrapper, public class triangle, we've got an opening curly bracket, and we've got a closing curly bracket right at the end. But then inside, we've got the definition of one field, and it's a field called color, and the data type for that field is string. And the way that we specify that is we say private string color semicolon. I'll say a little bit about what private and semicolon mean at a later stage. But the key idea here is that fields or data items inside a class are defined by giving a name to the data item, in this case color, and a data type to the item, in this case string. And then the next member that you can see inside the class is a constructor. Now we know it's a constructor because it reuses the name of the class in its definition. So the class is called triangle, the constructor is called triangle. And it's important to note a couple of differences between the outer wrapper of the class, which says public class triangle, and the constructor's definition, where it says public triangle and then a pair of round brackets or parentheses. So superficially, it looks like the outer wrapper of a class, but there are some big differences. So the word class is not in the constructor, and the class wrapper doesn't have these parentheses within it. But the fact that it's called triangle, it's inside the body of the class, tells us that this is a constructor. So the place where the fields of the class will be initialized. And inside the body of the constructor, so the constructor again has a pair of curly brackets, an opening curly bracket and a closing curly bracket. Inside those two curly brackets, we've got what's called an assignment statement. And you can probably work out what's going on there. We're setting the initial value of the color field to be green. In other words, every triangle that we create from this class will be green. And if we want a different color triangle, then we have to take a separate stage after creating it of changing its color to something else. We can't get a different color triangle simply by creating a triangle. We need to change the state of the triangles we create, because the constructor will always initialize the triangle's color to be green. Now that doesn't mean that we couldn't write a constructor in which it's possible to create a red triangle or a yellow one, or allow the creator of the triangle to say what color we want it to be. But we're just keeping things simple at this point and reproducing what's in the source code of the examples that you've seen so far. So we've got a field, we've got a constructor inside the triangle class. Let's look at those same things in a different class, in the ship class. And again, I want you to observe and think about the similarities and the differences so that you can then imitate that when writing your own classes. So here are some simple internals of a ship class. Again, we've got the outer wrapper, public class ship. We've got a curly bracket immediately afterwards and a closing curly bracket at the end. And then inside, we've got the definition of a field. The field's name is speed. So it's going to, every instance of this class will have a speed data value, and the type of value is an integer, or in Java we write int, we don't write integer out in full. So this says speed is a item of data inside a ship, and the type of data is integer. And the next thing in the class is a constructor. Again, we note that the constructor has exactly the same form as the constructor for the triangle. So we've got public and then the name of the class, ship this time instead of triangle. And then we've got that pair of round brackets or parentheses immediately afterwards. So you might like to compare what you see there with what we saw with triangle. Okay, so the constructor style, structure, contents is very similar. Public triangle, pair of parentheses, in this case public ship and a pair of parentheses. And then we've got another pair of curly brackets. This time we're initializing the speed field, not a color field. And so our assignment statement assigns an integer value to the speed field. In this case, we assign the value 5 to the speed field because we want all ships when they're created to be going at 5 knots. And again, we could define a different value. It doesn't have to be 5, or we could make it that when a new ship is created, it's not going at any speed at all. This is just an artificial initialization of a ship-like object. But spend some time thinking about what we see here. Triangle class with a field of type string called color, where the constructor initializes that field with a string value. And here we've got ship class with a field called speed of type int, and the constructor initializes that field with an integer value of 5. And so now I want you to think about how a simple ticket machine might look. And we'll just focus on one particular field within the ticket machine. So using observation and imitation, how would you write the outer wrapper of a ticket machine class? How would you write a balance field? What kind of type should it have? Is it a type that's similar to the speed field that we saw in the ship class, or is it similar to the color field that we saw in the triangle? Which of those would you imitate more closely in defining a balance field inside a ticket machine class? And then, having decided on the correct type for a balance field, how would you write the constructor of the ticket machine? What name should the constructor have? Should it be called triangle? Should it be called ship? Should it be called ticket machine? Use your observation, use imitation with appropriate adaptations for the ticket machine class. And then inside the body of that constructor, between an opening curly bracket and a closing curly bracket, what sort of assignment statement would you make in order to ensure that the balance field's initial value is going to be 0, so that every time we create a ticket machine object, it indicates that the customer has not added any money into the machine yet. So look at what we see with triangle, look at what we see with ship, observe, and then imitate in creating your own version of ticket machine. And what we'll do next is then look at how to do that in practice within the BlueJ environment.